Hi, this is Calvin Cox. This is part 2 of a 3-part talk. The first part dealing with why do we need to deacidify the world's oceans. The second part being this one, how to deacidify, what the calculation would be. And basically all the calculation is based around 1 gallon of seawater. This is just, of course, a representation. And how many teaspoons of calcium oxide it would take to change 1 gallon of seawater from a pH level of 8.1 to 8.24. So this calculation I'm going to do, it's all based around changing 1 gallon. I do not really know how many teaspoons. Maybe it would only be half a level teaspoon, maybe it would be up to 4 teaspoons. So I went ahead and decided to go with 4 teaspoons is what it would change, how much calcium oxide it would take to change 1 gallon of seawater. And the interesting thing about numbers is, it's just as important sometimes to just establish some number to work with. It doesn't necessarily at this point have to be the correct number. Okay, eventually, obviously, it has to be the correct number. But it's the thing about establishing some number. It allows you to begin to think and get your head around, you know, how would you possibly make something work? What would that number be? And so you can always adjust the numbers later, and that's what I'll do when I get more information later. But let me see here. We had to figure out, really one of the hardest parts was figuring out how many gallons of seawater would be in 1 cubic yard, and then figuring how many cubic yards in 1 cubic mile, and then figuring how many cubic miles would be in 1 foot of seawater if you were to remove 1 foot of seawater off the surface of all the oceans. How much would that be? In other words, that gives you some volumetric, you know, however large the number would be, which happens to be 26,500. It's actually 515 cubic miles. And that, again, gives you another number you need to know in order to make your final calculation. Let's just go through this real quick. Okay, there are 27 cubic feet in 1 cubic yard. And there are 7.48 gallons, okay, in 1 cubic foot. So if you times the two, 7.48 times 27 gives you 201.96 gallons per cubic yard. Okay. Now, at this point, what I did was, then I said, now remember, this is just a guess. I said that 4 level teaspoons of calcium oxide would be required to change 1 gallon of seawater from a pH of 8.1 back to 8.24, which the oceans used to be at a couple hundred years ago. Now, so 201.96 times 4 teaspoons gives you 807.84 teaspoons per cubic yard. Okay, then I divided 807.84 by 48, and the reason 48 is because there are 48 teaspoons per cup. Okay, and so 807 divided by 48 gives you 16.83 cups. Okay, which equals basically a dry gallon. Just a little over a dry gallon. Alright, then I took this number, alright, and then now we have how much we need for 1 cubic yard. Alright, so 1 cubic yard, 3 foot by 3 foot by 3 foot. would basically require this much, a container just a little more than this, filled with dry calcium oxide to change that seawater back. So then it became necessary to find out, okay, we know how much it would take to change 1 cubic yard, so how many cubic yards are in 1 cubic mile, okay? So I took a mile is 5,280 feet. I took 5,280, divided it by 3, because a yard is 3 foot on all 3 sides of it. It came up with 1,760, okay? So then I went so then that would be on one side. In other words, this top plane would be 1760 by 1760 would be 3,097,600 squares on this top plane. And then to, of course, give it depth and get the total number, you have to go by 1760 again, which gives you 5,451,776,000 cubic yards per cubic mile, okay? Then that number times 26,500, okay, that's taking 1 foot off the surface of the whole ocean. It's just giving you, you're not removing the water from the surface of the ocean, you're just figuring what depth and how much that would be to give you some number to begin to work with, okay? So 26,500 times how many cubic yards per cubic mile gives you 100,000 million billion trillion. 144 trillion, 472 billion, 64 million cubic yards around the surface of the whole Earth for 1 foot deep. Okay. Now, we know that 1 gallon is basically 8.8 pounds. Okay. So I took how many cubic yards times 8 gives you 100,000 million billion trillion quadrillion. 1 quadrillion, 155 trillion, 776 billion, 512 million. Divide that by 2,000, okay? Because places that dig calcium oxide, they dig it by the scoopful, which is tons. So it makes more sense to convert it back to tons. So divide by 2,000 will give you 577 billion, 888,256,000 tons of calcium oxide. Okay. Now there's an issue of that's how many tons of calcium oxide would be required to change 1 foot deep of seawater around the surface of the whole ocean. Now the area that scientists are primarily concerned about with ocean acidity, mostly at this point, is the first 300 feet deep of the ocean surface. And the important thing is just to begin to change the pH level back. Okay? It doesn't have to be all at once. And I really don't think the way that you would do it would be to only change 1 foot deep of seawater. That doesn't really make a lot of sense. You need to change a deeper section at one time. The third talk I'll give is going to be about how you would apply, how would you go about taking this calcium oxide and applying it into the ocean water at what depth, or how deep of a section at one time to slowly begin to change back the ocean pH level. So this concludes this talk. Thank you.